Tax Chemistry Review, questions 1 and 2. Number 1 says, the table shows properties of 4 liquids that are insoluble in water. Now real quick, insoluble means do not dissolve. Okay, so it does not dissolve. These do not dissolve in water. If the 4 liquids are poured into an Erlenmeyer flask containing water, which liquid will form a layer below the water? Just so you know what an Erlenmeyer flask is, it's the one that bows out like so. Okay, this is an Erlenmeyer flask. So if I've got water in there and I pour these 4 liquids into this flask, we want to know which one's going to form a layer below the water. So which one's going to sink to the bottom? Well, if I look up at my information, I've got a description which tells me color, that it's flammable or non-flammable. Flammable meaning that it can burn. Okay, so flammable means it will catch fire. Non-flammable meaning it will not catch fire. Okay, yellow mixture with strong odor, so I know it has a strong smell. And viscous, pale yellow oil. Viscous means that it's thick, it pours very slowly. So if I were to pour it, it would pour slowly. So now I look at the other information I have density and I have boiling point. Well, only one of these is going to help me know which one's going to sink to the bottom. And what helps me know if it's going to sink or not is density. Something that is more dense will sink to the bottom of another liquid. So if I were to pour all of these in, the one that is the most dense will be at the bottom. So this number right here is the biggest of my 4 numbers, which means it will be at the bottom. It will also go to the bottom of the water because water has a density of 1 gram per milliliter. So because this is greater than 1, it will sink below the surface of the water. Okay, it will be at the bottom of the flask, the water will be on top, and then these will be floating up above that. So my correct answer is A for liquid Q. Number 2 says, a student compares the viscosities of 2 solutions at room temperature. The student uses a metal block and equal volumes of the 2 solutions in identical containers. Which procedure would provide the best comparison of the viscosities of the solutions? Now, in that question above, I said viscous means that it is thick and it pours slowly. So viscosity has to do with the resistance to flow. A liquid with a high viscosity is going to move slower than one with a low viscosity. So I'm going to look at answer choice A, determining whether the block raises or lowers the density of either solution. Now if I have a block in here and I see if it raises or lowers the density, that's only going to tell me about the density of my total solution. It's not going to tell me about anything about just the solution itself. So that doesn't look good to me. Let's go on to B. Determining whether the block raises or lowers the temperature of either solution. Well, temperature doesn't have anything to do with knowing the viscosity of the solution. Now, if I heat up a high viscosity liquid, I can actually lower the viscosity because the molecules will move faster. And remember, viscosity pertains to its resistance to flow. So if I have something with high viscosity, it'll flow slower. But think about like syrup. Syrup is high viscosity. If I heat it up, it will flow faster, but that's not going to tell me if syrup itself has a high viscosity. So I don't want to look at the temperature. I don't want to see what it changes to. I want to know what's true about it right now. What is the viscosity of the solution? So let me look at answer C. Measuring the volume of the liquid, volume of liquid the block displaces in each solution. Well, if I measure the volume of liquid the block displaces, what that means is that I have a container with my solution in it. I put the block into it and it's going to raise up. It's going to go up a little. That amount it goes up is called its displacement. How much of that liquid does it displace? What this will tell me is how much space, how much volume that block took up. It'll tell me the volume of the block, but it won't tell me how slow that substance is flowing. So that's not very helpful either. Now let's look at D. D is measuring the time it takes the block to sink in each solution. Well, I know that if it resists flowing, it's going to flow slower. So this makes sense to me. If I put the block into the solution and I see how long it takes, well, a high viscosity liquid moves slowly, so the block would move slowly through it. If it's a low viscosity substance, then the block would move quickly through it. So this right here, D, is our correct answer. And if you have a question about viscosity on your test, there's two ways that they're going to ask it to you. Either we want to look at how much time it takes something to go through the solution, or how much time it takes for that solution or that liquid to, say, flow down a ramp. So I'm either going to measure the time it takes for something to travel down through it, or I'm going to measure the time it takes for the liquid itself to travel down. So if I were to put drops of this liquid onto a ramp, we'd see how long it takes for that liquid to make it down to the bottom. Imagine if I did that with syrup, how slow it would be. That'd be a high viscosity liquid. Or if I did this with water, how it would just whoosh down the ramp, and it'd be very quick, so it'd be a low viscosity solution. So viscosity is resistance to flow. Make sure you know that for your test.